Hello, everyone. We're going to go through a really quick lesson on states of matter and how they change. Okay, so we're going to start by looking at solids. So solid substances are very rigid. They do not change their shape very easily, and they have a very specific volume or amount of space that they will take up. Thinking back to our ice melting lab, our ice cubes were solids. They had a very predetermined shape. They were rigid in their structure, and they took up a very specific volume. And if we could get way in and look at the molecules that make up these solids, we would see that they're very tightly compact. And this is where their rigid shape comes from. There's not a lot of movement between these molecules, and that makes it hard to squish or compress a solid. We can't really change a solid's volume or its shape easily, depending on what the solid is. So we like to look at two factors when determining a state of matter. We look at their shape, and we look at their volume, the space that they take up. Now, liquids, on the other hand, like water, have much more movement in their molecules. Their shape is not fixed, it's not determined. And you can see from the structure of their molecules, if you could get right in there and see way down to this level, you'd see that they're not as tightly packed. They're able to move around each other a little more, becoming more fluid. And the thing about liquids is, though the space they take up, their volume is very determined, their shape is not. They will take the shape of any container that you put them in. You could have the same amount of water in a teacup and pour that water into a flask, and that same amount of water again into a pot, and it's just going to take the shape of whatever container you put it in, but its volume, the space that that amount of water takes up, will remain the same. And gases, like this water vapor coming off of this hot pool here, water vapor is a gas, and gases are very much more fluid. Their structure here is kind of haphazard. The molecules move freely all over the place, bouncing around, and they'll move wherever they can to spread out in a way. And so they will also take the shape of any determined container you try to put them in. And their volume is very easily changed because they can move and spread out. Their volume is not determined, it's not definite. And you can change the volume of a gas by either squishing molecules closer together or allowing them to expand and spread out. Okay. Liquid water, as we know in our water cycle, will evaporate away up into the sky and create clouds. Okay, so that liquid water that's very determined will evaporate away into these molecules that just spread out into our environment. And thank goodness for that, even if we don't like rain. Now again, defining states of matter is relatively simple. We look at two factors. We look at their shape and we look at their volume. And we say, is their shape and volume very definite and determined or rigid, or is it not? And so solids have a very definite shape. And volume of a solid is very definite. It's hard to really change that volume. Liquids, on the other hand, liquids do not have a determined shape. They will take the shape of whatever container you put them in. However, their volume is very specific. It's very defined. And so we say a liquid has a definite volume. And gases, not a definite shape. It'll take the shape of anywhere it is, moving all around, free flowing, and its volume can be changed because it will spread out, or we can compress it. So that's how we define a state of matter. Here we see our what we call a molecular model of solids, liquids, and gases. And you can see solids here are very rigid, tightly packed structure. And liquids lose that rigid structure and become more fluid and free-flowing. And gases even more. They start to flow all through the space in which you let them. And it's important to know that the state of matter is all determined by the temperature of the environment it is in. When we have liquid water, you're drinking water, and it's room temperature, you've left it out on the counter. Its molecules are all free-flowing, but staying right there. And if I want to change this liquid water into ice, I want to make it cold and rigid, I simply have to put it into the freezer. I have to reduce or lower the temperature the water it is at, and I can cause it to shift into its solid state. On the other end of that, if I want to take ice and make water, I simply have to take it away from the cold environment and allow it to melt. Okay, and it's the temperature at which you're leaving a substance that changes its state of matter. Okay, and likewise, I could heat water up and create it to go into its gaseous phase, turning into water vapor. I could boil it away in a pot on the stove. I simply have to change the temperature of the environment for the substance. So again, what causes a substance to change its phase? What causes the matter to change? If I add heat to this solid, I'll cause its molecules to start moving and shaking, and next thing you know, it's changed phase and it has melted into a liquid, and these molecules are absorbing the heat energy and they're moving around more and more. And if I continue to add this heat energy, if I increase the temperature, I can get this liquid to change its shape again, or its state of matter again, and move into its gaseous phase where these molecules are moving even faster and spreading out even more. And on the opposite end of that, I can take the heat energy away. I could reduce the temperature, and these molecules start to move a little slower and slower until they've transitioned back into their liquid phase. And if I continue to remove the heat energy and take or reduce the temperature, I can get these molecules to slow down even more and more and become more compact until they are in their solid state again. So I hope that this helps clear up what a state of matter is and how we define it, and then what it is that causes a substance to change its state of matter. If you did not already complete the worksheet from last class, which showed you a big phase change diagram, I want you to try to use this video to help you complete that worksheet. Okay? How do we determine this transition from a solid to a liquid? Okay, how do we define or discuss a liquid changing into a gas? What are those terms? Okay. I hope this was helpful to you, and have a lovely day. Enjoy this beautiful weekend.